Hello everyone. Today is day 3 of Leetcode 75 challenge. Let's begin with the third question. Problem number 1431. Kids with greatest number of candies. I will request you to read the question before going to the solution, as I will directly explain the question in this easier manner through the PPT. So let's directly enter to the PPT. Okay. What does the question says? You have n kids, each with some candies. Fine. Given an array candies, where candies of I is the number of candies the ith kid has. You also have extra candies that you can give to any kid. Okay. You need to check for each kid if they receive all the extra candies, will they have the most candies or it be equal to the maximum. Return a Boolean array, true if the condition satisfies, false if not. So constraints of the problems are n is length of the candies, and n could be from 2 to 100, and candies of I, basically the values for each index would be from 1 to 100, and the extra candy, which would be an integer, would be of difference between length, which range from 1 to 550. This question is trying to say that we have an array which consists of n number of kids. Fine. Each kid has some candy. Could it be 3, 4, 5, anything? Now the question is trying to say that you have extra x number of candy. So in this array, suppose there is a kid which has the maximum candy. Suppose Max, he has the maximum. He or she has the maximum candies. Right now, the question is, if we add this extra candy X to each and every kid's candy, does it max out to greater than max or equals to max? For example, if here is 1, max candy is 3, and extra candy is 3. So 3 plus 1 gives us 4. So yeah, this satisfies the condition. So we can say that, so we will return the output as true from here. So this question, so if I summarize the question more simply, it is saying that you have array of n kids, each kid has x candies, and out of those, one kid has the maximum candy, x plus 1, take it as x plus 1, and you have given extra candy y. If you keep on adding y to each and every student kid's candies, does it equals to or gets greater than the x plus 1 maximum kid, student with maximum candy, kid with maximum candy. Now let us understand the input and output of the problem. Yeah, so we're given the candies array and extra candies, as I was trying to explain you in the summary of the problem. So let it be kid 1, kid 2, kid 3, kid 4, and kid 5, right? So each kid has kid 1 has 2 candies, kid 2 has 3 candies, kid 3 has 5 candies, and so on. Now the output is true, 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 false, and true. How? If you see, if we add 2, 2 plus 3 gives us what? 5, right? And what is the maximum candy in the array? 5. So it satisfies the condition of equal to or greater. So true. Now second kid has 3 candies, and 3 plus 3 gives us what? 6. So it also satisfies the condition. We have 5 plus 3, 8. So yeah, it will be of course greater than the greatest element. So true. Now we have 1. 1 plus 3 gives us 4. But 4 is not greater than or equal to the maximum candy 5. Then again we have 3. 3 plus 3 is 6, and it will be 6. So it is greater than 5. So true. So this is what is explained in the input output example. Now, what would be the intuition for solving the problem? Let us understand this way. Imagine you have a group of kids, each holding a different number of candies. Now, you also have a few extra candies that you can distribute. The question is simple. If you give all the extra candies to one specific kid, will they have the most candies among all? To figure this out, First, we will try to find out how many candies the kid with highest count currently has. Basically, which kid has the maximum candies in the array. Then for each kid, we will add the extra candies to the count and compare the total new with the kid which has the maximum candy. If it matches or exceeds the highest count of the candies which particular kid has, so they have a chance to be the kid with the most candies. Otherwise, they still don't have enough. This way, we can determine one by one whether each kid has the potential to be the one with greatest number of candies. It is like a fun contest where you check if a giving boost to a someone can make them the best. So this is the intuition of the problem. Let's go to the approach. What would be our first step of the problem? As I mentioned earlier many times that you have to compare each kid with that kid which has the maximum number of candies, right? So what comes to our mind is that we traverse the complete array and we find the kid which has the maximum candies, right? Okay, and we will store that somewhere in this variable, max candies. Now, what would be our second step? We will create an empty list result to store answer. Why? Because as we see, the output requires an array which contains boolean values, true or false. So for that, we will create a result empty list to store the answer. For each kid, what we gonna do? We will, since we are traversing the array, for each kid, we will take the candy x of that kid plus extra candy, right? And we would check that if it is equal or greater than the max candy, right? Here, step 3. And if it is greater or equal to the max candy, we will push true into the array. If not, false. And at the end, we will return the result list in which we have the Boolean answer. Okay. So let's go through the code. Since we are given a function in which we have a list candies and an extra candy. Great. We have to return bool. So in the max candy variable, we will store the maximum kid which has the maximum candy from the candies list. We will create an empty result list. Now we're gonna traverse or we're gonna loop through the candies list and we're gonna append by putting in the condition that the candy, which is the value of each kid candy plus the extra candies, is it greater than or equal to the max candies? And we will return the result. Now the time complexity for this problem will be O of n because we're traversing the candies list of size n or length n. And space complexity would be O of n because we are creating an array list result and storing all our result in it, true or false, and we're returning it. So it would also take size n, which is equivalent to the size of the candies. So now let's go for the dry run of the problem. We have candies array 2, 3, 5, 1, 3, and extra candies is 3. Okay, what our code is doing? We're trying to find the maximum candies. Okay, okay, with the maximum candy. So 2, 3, 5, 1, and 3. So we can say that 0, 1, 2, 3, 4. So kid in index 2 has the maximum candies. Okay, great. We will store it here in the max candies as 5. Great. Now we're going to loop through this complete array and we will check one by one and append it to the result list. So Since you can see here, we're appending into the results list. So what we're going to do is that we can pick index 1 plus the extra candy 3 and we will check, okay, if it is true. So the result which we have, result list, it will have the value true in it. Okay. For 3 and for, okay, this is done. This is done. Then we have 3. 3 plus 3, it's 6, right? So it is greater than 5. So true. Then we have then we have 5 plus 3, which is 8, of course, true. Then we have 1, then we have 1 plus 3, which is not greater than 5 because it is 4. So it does not get equal to the true condition. So we push false. And similarly for the last one, we get true. Fine. And we return this result. Now let's go to the lead code and code it out. I will add exactly the same code which we have understood previously in the PPT. We have the variable max candies result list for candy in candies result dot append candy plus extra candies is greater than equals to max candies. Just return result. Yeah. Now submit. Let submit the problem. So yeah, everyone, we have successfully solved our problem, and the runtime comes out to be 0 milliseconds. So it is an optimized code. So you could refer to my GitHub repository for the code files. Thank you, everyone.